Hello! In this video I'm going to show you how to add and subtract fractions with same denominators and also fractions with different denominators. So I'm just going to explain what I mean by denominators and just what the different parts of a fraction tell us. So in this shape here I've got 1, 2, 3, 4, 5, 6, so 12 different parts. So if I was to shade in one of those parts, I would say I've got 1 out of 12, which we can write as 1/12. If I shaded in another part, I've now got 2 out of 12, which can be simplified as a fraction to say that I've got 1/6. So I've done that by dividing both numbers in the fraction by 2. So we say those fractions are equivalent. And you can see if you look at that shape, if you just look at the vertical kind of slices, those columns, that there are 6 of them. So I've got 1 out of 6. It's the same thing, it's the same 3 out of 12. I keep shading, I've got 3/12, 4/12, 5/12, 6/12, or a half, and so on, 7, 8, 9, 10, 11, and then 12/12 for the full thing. So if I wanted to add two different fractions, if the number on the bottom is the same, it means we're talking about a shape cut into the same number of pieces. So if I go back to the beginning, say we had 3/12, then a different colour, I'm going to shade in 5/12. So you can see I've got 3/12 because I've got 3 out of the 12 parts, and then in orange I've got 5 out of the 12 parts. If I want to add those together, it's just seeing how many I've got in total. The shape is still broken into 12 parts, but instead of saying I've got 3 and also 5, we just add those two top numbers, or the two numerators, and say we've got 8/12. But then that can get simplified, just like I did earlier. Look and see what can I divide 8 and 12 by. And you can divide by 2, but there's a bigger number in there, bigger factor of 8 and 12, which is 4, which will just get me quicker to the most simple version of that fraction, which is 2/3. So this shape would be the same if I was to block it differently and block it into 3 parts. 1, 2, 3. So they are equivalent fractions. So if you want to add fractions with the same denominator, same number on the bottom, then we just add or subtract the top numbers and then simplify where we can. The same goes for subtract. If I started with 11 of those 12ths, and then I wanted to unshade 3 of those 12ths, I would have 8 of those 12ths, or 2/3. Okay, looking at one without the diagram, say we had 4/9 of a shape and wanted to subtract 1/9. Because the number on the bottom is the same, we know that it's been broken into 9 parts. I did have 4 out of the 9 parts. Take away 1 out of the 9 parts, I've got 3 left out of the 9 parts. And that fraction can be simplified. These numbers both divide by 3, so I'm left with 1/3. Okay. We have a little bit more work to do if we have fractions that have got different numbers in the bottom. So 1/2 plus 1/3. We can still add them, but we just need a different way of thinking about them before we get to that point. And the reason for that is if I show you in a shape, so if I've got 1/2 of this shape, look like that, I'll shade it in. Oops, didn't shade very well. And 1/3 would look like this. So that would be 1/3 that big section at the top, because I would fit one, then another one at the bottom, and another one off to the left. Would fit 3 of those shapes in a full thing. That's why it's 1/3, one broken into 3. And if I shade that in, That's a half plus a third. But if you had half a cake and then another third of a cake, how could you say how much of it you've had in total? So that's what we're trying to do when we're adding those, is come up with a simple way of saying what fraction we've got. But we can't just say it's 2/3 because it's not 2/3, that's 1/3 there, and we've got a different fraction, a different size on the other side. So what we do is we think of both fractions in a way that helps us compare them to each other. So if I just split this shape differently, you can see an equivalent fraction to a half, an equivalent fraction to a third, that makes them like each other. So a half is the same as 3/6. So just like with simplifying, I can do the same thing to top and bottom to get an equivalent fraction, but instead of dividing, I'm multiplying up. I've got 3 parts out of 6 parts in total now. And then the pink part, the third, if I've broken it into 6, I have 2 out of 6 being equivalent to a third. And if you look at the numbers, both numbers being multiplied by 2, so we didn't really need the shape once we get used to what's going on here. And now it's just like the ones on the last page. It's broken into 6 parts, 6 slices of cake. You eat 3 of them, then another 2 of them. You've eaten 5 out of the 6. So once we get our fractions with a common denominator, they're just like the original fractions. If we look at another one, quarters and thirds. So you might want the shape to help you, or you might just want to look at the numbers. So with the shape, we're thinking what size of cake, or what size of slice, could you use to get a quarter easily, but also get a third easily? So really you want a number that you can get a quarter of and a third of, which is why I've split this one into 12. A quarter of it would look like that. Sorry, that's a third. A quarter of it would look like that. That's a quarter because it's split into 4. There's 1 of them, 2, 3, 4. There's 12 blocks in total, so a quarter of them would be 3. So a quarter is the same as having 3 out of 12. And again, you don't really need the shape once you spot what's going on with the numbers. If you're cutting it into 3 times as many pieces, you'd need 3 times as many of the pieces in our fraction. So bottom number times by 3, top number times by 3. These are equivalent. A third, well, I had 12. A third of them would mean I've got 4 of them. So that blue part there is equivalent to a third, because it's 4 out of the 12. And now if I want to know what fraction of this shape I've got shaded, in total there are 7 shaded parts out of 12 parts. Okay, so to sum up, to add and subtract fractions, you want to have the denominator, the bottom number, the same. They might already be the same, in which case all you do is add or subtract the top numbers and then simplify if you can. If they're not the same, we need to get a common denominator, and that's the first number that both denominators can easily get made into. And then we're just like before, same number on the bottom, add or subtract the numbers on the top.